So today is a day that I'm really excited for. If you followed along in the last 9 videos, we set up the electronics for our drone in terms of the HereLink unit, the motors, a BEC, and kind of set the stage for all the components to let the drone fly under manual control. Well, today we're going to start to hook up our companion computer. So we're going to walk through getting a Raspberry Pi 5 configured and talking to the system that we've set up. And to do that, I've bought a SwitchBlox Ethernet switch. So it's a tiny little Ethernet switch that my hope is to be able to connect the Raspberry Pi to the switch, and then from the switch connect to the Herelink Air Unit and let all the MicroSD commands and telemetry flow between them. Now ultimately someday I want to get a camera connected to this Raspberry Pi as well, and I have a Google Coral TPU that my thought and hope is to let it to do some sort of object recognition and autonomous flight control. So today's going to be a little bit of a hard one. We'll get into some different networking concepts. We'll have to wire this stuff up. I'm not exactly sure on how all the cabling is going to work between these, but it should be pretty fun to walk through and figure all this stuff out. So let's head on over to the bench and get started. All right, let's talk through the componentry that we need for today to make all this successful. So the first item that I have is the SwitchBlox unit itself. Okay, and it comes with this wire that you're going to plug into the power in port. It's got 2 red and 2 black, and what I did was I soldered that to an XT30 male connector. Okay, if you remember in video 3, I think, maybe 4, we started to set up all the electronics, and in that video I built these little harnesses, these little kind of octopus cables that have multiple XT30 female connectors connected to bullet connectors in the 2 spots for the speed controller connections that I'm not using on this core carrier board. Regardless, you just need to give it something between 5 and 60 volts of power. Okay, and in your SwitchBlox box as well, so this is the box that it came in when I ordered it. And it was sitting here. I already took it out and hooked up the cable and powered it. But what you also get is 5 RJ45 connectors with the Pico blade connector on the other end that will then let you plug it in to one of the 5 Ethernet ports on the SwitchBlox. Okay, so that's step number 1. You need to be able to power your SwitchBlox and do some soldering and be sure that you can bring power to this. Okay, this is how I did mine. Now what I'm going to do is I'm just going to plug it in to my power supply here. And because this is just from the speed controller itself, this gives the battery voltage. So when I end up connecting a 12S battery up to this, I'm going to have 44.4 volts approximately going to the SwitchBlox. Okay. Now, a couple other components you're going to need. I bought a USB-C cable, and this is listed in the bill of materials. And what I did was take the red and black wires, the power wires, and I connected it to, can't remember the type of connector this is, but I connected it to one of these, which is what I'm using throughout my drone for kind of the 5 and 12 volt power supplies. So all I did was cut the cables, kind of splice in the middle, put some heat shrink tubing. So now I have a USB-C connection that I can give to a 5 volt power supply. In the earlier video, I configured this BEC component up above. Let me see if I can get to that. So it's this guy here. And one of the good things about it is it has a dedicated 5 volt, 4 amp output. And that is what I'm using for the Raspberry Pi connection to give it plenty of power. Okay, so I'm going to go ahead and just plug those together. And now I have a good 5 volt supply to my Raspberry Pi. Okay. 2 other things you're going to need. This is the HereLink Ethernet adapter. It plugs in the top of your air unit, so there's a little rubber cover on it there that you pull off next to the fan. And then you can go ahead and plug in this adapter and it'll give you an RJ45 connection. When I actually install this in the drone in a future video, I'd like to clean up this wiring and not have something as bulky as RJ45s, but for today, that's what I'm going to go with, just to get this working and prototyped as easily as possible. Okay. I also wanted to mention, with my order from BotBlox, I ordered a couple extra cables. So I got these. I ordered 2 more RJ45 to Pico blade connectors. But then I also ordered these Pico connectors with tinned wires on the other end. And what that will let me do is build some other custom connectors to connect to other devices, such as a camera that may have a different pinout or connector required. The air unit has its own connector, and so forth. BotBlox also makes these adapters. So they give you an RJ45 connector, and then they give you a common connector for many different pieces of hardware in the ArduPilot ecosystem. So these, looks like it has several different JSTGH pinout connectors. For example, there's one there for a CubePilot, one here for switch blocks, right? So you can connect these things directly. So I got 2 of those just to have some flexibility and be able to quickly figure some stuff out. Not sure I'll use it all, but that is what I ordered in addition to the switch blocks to be able to prototype effectively. All right, what else do you need? I had this in an earlier video too, but I got a micro HDMI cable. So this is going to go between the HereLink Air Unit and the Raspberry Pi to send a video feed for right now. We connected it in an earlier video. I disconnected it just to show you what we're working with here. So I'm going to go ahead and plug that in to the port closest to me. So in the air unit, I've got an RJ45 connector coming out of it. I've got a micro HDMI connector. And then we have our switch blocks, which is powered up over here from the battery voltage. And I have a 5 volt supply to the Raspberry Pi. Okay. Now for the Raspberry Pi itself, it comes looking like this. This is a Raspberry Pi 5. And I did buy the active cooler kit for it. So we're going to go ahead and install that as well. If I open it up and pull it out, it's got a fan, a heat sink, and it's got some, looks like some thermal type of conductors on the bottom that'll attach to the circuitry. So the way this installs, the box actually shows you on the top, right? The fan is going to go closest to the RJ45 port on the Raspberry Pi, or I'm sorry, to the USB ports. And there are 2 plastic connectors that are spring-loaded that looks like they will just snap right in to the 2 holes indicated in the Raspberry Pi. And those are the holes that are just outside the normal standoff holes. Okay. So I'm going to go ahead, peel off the paper. Make sure you do that, otherwise you won't have good conductivity and thermal characteristics. Now, up here, in the top of the Raspberry Pi, there is a little cover over the port for the fan. So I just pulled that a little tiny plastic piece off, but you want to make sure you open that up. That's this port up here. Okay, I'm going to go ahead and plug this in. So the cable is going to connect right in here. All right, and then this should sit on top of the appropriate chips. It's a little sticky, so line it up as best you can before you stick it in. And then these spring-loaded clips, you're just going to push through, and then it'll use a little bit of pressure to keep the fan and the cooler tight to the chips. Okay. So there's our Raspberry Pi. Now, the next thing I want to do is I'm going to power it up. Let's just make sure everything's working. So I'll take this HDMI cable. I'm going to plug that into one of the micro HDMI ports on the Raspberry Pi. And I'm going to plug in my USB-C cable into the Raspberry Pi. So I should now have good power. I'm just going to kind of set these around. Okay, so there's our switch blocks here. There's our Raspberry Pi. Let's make sure we're not touching any other wires inadvertently. Okay. And I should just be able to power it up. Hopefully we see the fan spinning on the Pi. Switch blocks gets power light, and we'll know we have things powered correctly. So over here, I got my battery connection. Just going to plug that in. All right, we got a green light on our switch blocks. Okay, so I'm going to assume that is good. And on the Raspberry Pi itself, the fan is spinning. And we've got a green light on the Pi too. So I'm going to take that as a good sign that we've got our devices powered on appropriately. And we'll move on to the next step, where we're going to have to install an operating system on this Raspberry Pi so we can start to do something with it. So to do that, I'm going to disconnect the battery, turn everything off. I have a SanDisk Extreme MicroSD card and 128 gigabytes. What we're going to do is open that up, and we're going to need to use the Raspberry Pi imager on the computer in a second here to install the operating system on it, and then we can install this card in the Pi itself. Okay, so it comes with two pieces. The important one that you need is the micro SD card on the right here. This other black piece, you can throw it away if you don't need it. It's just an adapter for the micro SD card to, I can't remember what format the bigger one is, but you might have on a laptop this bigger card format that you can slide in, and this will let you adapt your micro SD card to it. Okay, so on the back there's a little bit of plastic that I'm going to go ahead and just kind of score here. And then there's the micro SD card. So the micro SD card installs in the bottom of the Raspberry Pi in this little silver slot here. But don't install it yet. We've got to use a computer to install the operating system. What I have is a USB to micro SD card adapter. This works better in my computer than the other adapter that came with it. This is a Transcend one, USB 3.0 that I bought off of Amazon. USB Type A port on one side, and then on the other side I can do an SD or a micro SD card inside of it. So what I want to do is take the micro SD card, and I am going to insert it into my USB adapter. Okay, so it just slides in to the adapter. If you buy a different one, you know, it's going to look a little different, but they all function pretty much the same. So what we're going to do now is go over to the computer and install the operating system, and then we should be able to put this micro SD card in the Raspberry Pi and actually have it boot up. All right, I'm going to head over there now and start recording from there. Okay, what I want you to do is go over to the GitHub page that I linked to in the description of this video. And if you scroll down from the main page, there's a link to the wiki and documentation folder. We're going to go into that. And then if you scroll down on this page here, there's a link to video 10, onboard computer and Ethernet. You're going to click there. In this page, I have a link to the Raspberry Pi imager, which you're going to need. So I'm going to open this in a new tab, and it will open up this page. You're going to need to download, if you run in Windows, the Windows version, and install it. Okay. Once it's installed, we just start it up by running the Raspberry Pi Imager app that'll be on your computer. I'm going to say yes. And it'll give you a couple options where we're going to choose the device, operating system, and the storage that we're going to install to. So what I'd like you to do right now is take your micro SD card and whatever adapter you've plugged it into and plug it into your computer. I just plugged mine in and it's telling me I need to format the disk. That's okay. We're just going to say cancel here. And it's okay that there's not a recognized file system. That we're going to install and format everything with the Raspberry Pi imager. Okay. I'm going to minimize this page so you can kind of see this as is. So the first step is going to be choose your device. In my case here, I've got a Raspberry Pi 5. Your second step is going to be to choose the operating system. You can install Pi OS. Some people may want that if they want the graphical interface. For this drone, I'm going to end up installing Ubuntu Server 2404 to experiment a little bit with. So for that, I need to go down to Other General Purpose OS in this selector list here. And then from here, it'll give me an option to choose Ubuntu. Select that. And then from there, I can pick one of the Ubuntu versions. There's Ubuntu Desktop 2404 and Ubuntu Server 2404. I want the server version in my case. I don't need the graphical interface. This is going to be running on a drone. It's going to be headless. So I'm okay with that. I click on server and it's going to select it and put it in this operating system field. Next step, choose storage. Click that and you should see your micro SD card show up in the list somewhere here. If not, you might have a problem with your adapter that you need to resolve. I have a 128 gig card, so this is lining up nicely. It's telling me it is the Transcend USB device. So I'm happy that it's going to write to that destination. So I click on that. These three fields are now filled out with my settings, and I'm going to click Next. Now I like to do this part where I do apply OS customization settings. And I recommend you do the same as well so you can more easily boot into this, this Raspberry Pi and connect to it. So I'm going to press Edit Settings. And I've already pre-filled this out, but I gave my drone a host name. So you check that, and I call this Ubuntu 2204-drone01. And then for a username and password, I gave it both of those. I filled in Ubuntu for my username, and then I've given it a password that I can SSH and connect with. Configure wireless LAN. I'm going to give it the SSID of my wireless LAN here at my house, and I'm also going to type in the password to it. Make sure you type this stuff in correctly, otherwise if you make a typo here, it's not going to work. So be very careful with what you're typing. And additionally, the locale settings, I'm going to go ahead and set this to America, Chicago, and a US keyboard layout. Now there's other tabs at the top. We were just on the General tab. I'm going to go ahead over to the Services tab, and I want to enable SSH, and I want to allow password authentication. So that'll let me use a terminal program to SSH and type in a username and password to connect remotely from. And then this last tab, Options, are just items for when it's actually burning the image. What do you want to happen when it's finished? So I'm going to go ahead and press Save there. And then I'm going to press Yes. I do want all those customization settings applied as it burns the microSD card. So I click Yes. It gives me a warning that it's going to delete all the data. I do want to continue, so I'm going to say Yes again. And this is where it's going to go ahead and prepare itself and connect and write the image. It may take a little while on your computer. If you haven't already installed that operating system, for example, it would have had to go out and download that Ubuntu 2404 image first before it could write it to the microSD card. I already had it cached locally because I've installed one of these before, so it did not have to download. And then as it's writing, you get the progress meter telling you how complete it is, and you just wait this thing out until it gets to 100%, and then you'll be done. So I'm going to go ahead and stop talking for a minute, and when we edit this video, I'll speed this part up a little bit. Okay, now that it's done, it gives you this message telling you can remove the SD card from the reader. So I'm going to go ahead and unplug it from my computer right now, and then press continue, and we can close out of the imager. That's it for this step. Now we can go ahead and plug the microSD card into the Raspberry Pi, and it should actually boot up to a working operating system. Now that we have our microSD card burned with the operating system image, we're going to take that out of my USB adapter here, and we need to insert it into the Raspberry Pi. Now on the bottom of the Pi is this little, it's a little hard to flip over, but is this little silver microSD card holder. You're going to install it with the pins in the microSD card facing up towards the circuit board. So it just slides right in, you just push it in, and that's it. Okay. So it kind of sits in there. If you want to take it out, you just grab it kind of with the tips of your fingers, pull it out. All right. There's no really spring-loaded feeling or any sort of snapping feeling. You just push it all the way in until it doesn't go any further. So now that the Pi has the operating system installed into it, I want to do a couple things here to do a quick test. The first thing I'm going to do, I'm going to start my HereLink controller. Okay, so I'm going to power that up. And the thought here is we should be able to see a little bit of the HDMI output from the Raspberry Pi as it boots. Okay. And I'm just going to maybe set this right here for now. And I'm going to start Q ground control. Now Q ground control will normally start with the map, and in the lower left corner there's a little black box that says waiting for video. When it detects a video feed, it'll start to display it there. So now I'm going to go ahead and plug in this whole setup here, and things should start booting up. Okay, the Raspberry Pi has its green light on. It should be booting. What I want to do though is I'm going to press on this waiting for video section, and it swaps the views, and it actually already booted the Raspberry Pi. So you can see, it might be a little hard to see, but in the top of the black screen there, it says it's got the login prompt. Okay. So I could try it again. If I were to maybe just kill the power to this Raspberry Pi here. And then I'm going to restart it. Ideally, the video feed starts to update as it goes through its boot sequence again. And this thing's complaining because it doesn't have my ground control station connected. You can see everything streaming by though from the boot up process. Don't try and read it, you won't be able to read it. I can barely read it on the small display, but it just booted and I have a login prompt. So that's all good news. Now what we should be able to do is go over to the computer now, and because this is on my Wi-Fi network, I'm going to SSH in to this Raspberry Pi and apply updates. And then we should be able to start working on the actual Ethernet setup on this whole electronics assembly. So remember, ultimately I'm going to unplug this too. Remember, ultimately I want Ethernet connection from this Raspberry Pi to the HereLink Air Unit up here. And my thought is that will let me issue pymavlink commands and see the telemetry coming out of the cube. And then I don't have it yet, but I'm planning on getting an Ethernet enabled camera as well, so I can pull an RTSP stream off of it. And so I'll be able to connect that into the network as well and talk to the camera and pull its video feed. Additionally, for a later video, I've got this Intel RealSense USB camera that I am hoping to plug into the Raspberry Pi through the USB connection and do some computer vision and AI type of work. That also uses this Google Coral TPU, so this will help to speed up the inferencing and object detection. So future videos is when we get to programming and doing more fun stuff with this thing, but right now I need some base infrastructure and a network that lets these components talk. All right, let's head over to the computer. I'm going to power this back on and then head over to the computer, and we're going to SSH into this Raspberry Pi and install updates. See you over there. By default, your Raspberry Pi will attempt to get an IP address using DHCP. So if you have a router at home that is able to serve up DHCP IP addresses, it will automatically get one, assuming it can successfully connect to your Wi-Fi network. Now, the hard part is you're going to need to figure out what IP address your Raspberry Pi has. It's going to be unique to everybody. The best advice I can give you is go into your router's configuration page or your firewall's configuration page, and there should be a section that describes the DHCP reservations or active devices on your network and tell you its IP address. I have already done that, and so I'm at a DOS prompt here on my computer where, just to verify it, I can ping that IP address. So my IP address is 192.168.200.105 for the Raspberry Pi on my home Wi-Fi network. If I issue a ping command, you can see I'm getting replies from it. Now this, like I said, this might be hard if you don't have networking experience or totally understand how to get your device's IP address. You may have to do some Googling then on how to get the IP addresses of devices connected to your network. Or you can brute force it and just try and look for one. You know, a lot of devices will have 192.168.1. And then they'll start from 1. You can just start pinging from .1, .2, .3 and looking for a device that answers. Now you'll probably get other devices on your network though, and it'll be fairly inaccurate. But I recommend if you can get into the web interface for your router though, that's what you do. So since I know my IP address now, I'm going to use a piece of software that I have called MOBA Xterm, which is an SSH type of utility. I'm going to go ahead and just start a new session and SSH in and fill in the settings. So my remote host is 192.168.200.105, and I'm going to check the username. And if you remember, when I customized the OS settings, I said I wanted to have a username of Ubuntu to be able to log in with. This will be the normal user on that Raspberry Pi. Now, MOBA Xterm is paid software. You know, for personal use at home, I think I pay $50 a year to be able to have this for all my virtual machines at home and just be able to experiment and learn. You can also use some free software called PuTTY. If you download that from the internet, you know, you'll just log in, PuTTY, download, and you'll get to software that looks like this. Download PuTTY, a free SSH and Telnet client for Windows. And in fact, I'll go ahead and put a link to this software in the page for this video on the GitHub repository, just so you can get at it if you want to download and use this. Okay. So back in MOBA Xterm, I'm going to go ahead. I got my IP address and my username specified. I'm going to say OK, and it's going to go ahead and connect. Now, normally it would ask me for the password, but I did test this prior to filming this segment of the video, and it did work. And so it already just let me in. So from here, you get a command prompt, and you can see my power. It's complaining a little bit about my power supply because I'm not able to get quite up to 5 amps. That BEC I have supplies up to 4 amps. Maybe someday in the future I'll correct that, but I'm going to go with it for now. And it gives you some other information, such as if there are system updates that can be applied, and in this case there are. So I'm going to go ahead and update those. I'm going to type sudo apt update. Okay. So if you type that command, it's going to ask you for your password, which you just type again, and it'll go out and update the packages that it knows about that can be updated. So after you type that command, then I'm going to type sudo apt upgrade, and it'll go off and tell me all the stuff that it's about to update and ask, do you want to continue, yes or no? And at this prompt down here for do you want to continue, the capital letter is the default one. So if you just press enter, it's going to take that and go forward. So I'm just going to press enter, and it's assuming that I picked yes, I want to continue, and it will go off and apply the updates to this operating system. So it'll take a little bit, a couple minutes maybe, depending on how many updates you need to apply. And then once it's done, it'll come back to the command prompt, and we'll be able to move on with other things. So this does get us to a good baseline, though, where we have a Raspberry Pi. It is on our wireless network in my house, not the Ethernet network on the drone yet. And I'm able to talk to it from my computer and apply updates and work with that device. So next step is, once this finishes updating, then we're going to have to figure out how to get the actual onboard Ethernet working on the drone itself. So we'll let this go. It appears to be going pretty fast here. And once the updates apply, if it installs a new kernel, I usually like to reboot the device, and you can do that just by typing the command reboot when it's done. What I'll probably also do is just shut it down cleanly, and I'll show you the command for that. There's just a shutdown command that you can run. If you're not used to using a Linux terminal or an SSH prompt, ChatGPT can be your friend, or you can go into it and ask it questions like, show me the command on how do I shut down my Linux Ubuntu machine, right? And it'll give you the command for that. Almost done. About 67, 68, 70% complete now. Okay, the updates have finished. One of the things I like to do after installing updates after a while, just to clean up the disk and get rid of old packages I don't need, is run the command sudo apt auto remove. And if there's anything that it doesn't need anymore, it'll go ahead and just remove those from your device. Last command I told you I'd tell you about is the shutdown command. So if you just want to shut down the Raspberry Pi cleanly, you type in shutdown-h, actually sudo shutdown-h now. And that'll go ahead and just kill your connection and power that thing down, closing the file system and stuff appropriately, so it'll bring itself back up cleanly. Okay, I'm going to stop the video here. Next steps is to start working on the onboard Ethernet connections on the drone itself, and ensuring that we can get that to be able to start to talk to the Herelink Air Unit. All right, back in a minute. Now that we have a working Raspberry Pi that we can talk to it over the Wi-Fi network, we need to start to make the physical connections for our Ethernet network on board the drone. So what I want you to go grab are 2 of your RJ45 to Pico blade connectors that came with your SwitchBlox. Okay, and we're going to go ahead and plug those into each SwitchBlox port. So there's port 1 through 5. It shouldn't matter which ones you plug into. I'm going to just plug into these top ones, which is port 5 and port 4. Be careful you line the Pico blade connector up too. It only fits one way. Don't force it in the wrong way because you might end up bending the pins. Okay, it'll kind of click in when it's seated. Okay, so now we got our SwitchBlox connector with 2 RJ45s. Now what we want to do is we're going to plug one of these RJ45s into the Raspberry Pi. Okay, so you'll just click in. And then the other item that I have in the bill of materials is an RJ45 coupler. And all it is 2 RJ45 ports that we can plug into. And I did that because this HereLink Ethernet cable comes with a RJ45 connection on one end, and these SwitchBlox cables come with RJ45s. And I didn't have any way to route these together. I didn't want to make a custom cable either. So easiest way for right now, we'll just use this coupler and plug the cable from the SwitchBlox into one end, and the HereLink Air Unit Ethernet cable into the other. Okay? And that should do it. Now we've got an Ethernet connection between our Raspberry Pi and our Air Unit, and we'll jump over to the computer now and set up the static IP address on the Raspberry Pi so that it can talk to the Air Unit and the rest of the network. Also, really quick before we jump over to the computer, I want you to go ahead, power on your HereLink controller, and you're going to enable the Wi-Fi access point and connect to it from your ground station. And while that's booting, the other thing I want you to do is power up all these electronics, because we need everything running to be able to test this out and start to show the networking configuration. So while this is booting, the controller has booted, and we're going to go in and turn on the hotspot in here as well. Alright, that should let me now officially connect from the computer and show all the different test scenarios that I want to show off. Before we move on, I want to talk through the plan for the rest of this video and the different elements that I'll be walking you through and showing you. On the next slide coming up here in a minute, I'm going to give you a diagram of what our network will look like at the end of the day. It'll show all the different components, IP addresses, and key URLs that you might need to make sense of how all this networking is talking. I also want you to make sure that you're connected to the HereLink Wi-Fi from your laptop or your ground control station, whatever you're using. You'll need that so that you're on the appropriate network to be able to talk to our devices. I also want you to have the wiki open that I'm publishing for this video series. Just go to github.com/timarcher/drone, and I'll show you that in a second on where the page is for this video. It'll have lots of settings that you can copy and paste. It'll make your life a lot easier if you can just paste those right into the Raspberry Pi settings, or when we get to the last part of the video where we execute a simple Python program talking to the flight controller. So once we get rolling here in a second after this intro, we're going to assign the Raspberry Pi a static IP address. So it'll have a static IP on the drone's network and be able to talk to the air unit successfully. We'll also add a route so that the Raspberry Pi can ping and talk to the Wi-Fi access point network from the Pi. Okay, so this will let the Pi talk over the HereLink connection to the controller and to devices on the other side of the controller that are on the HereLink's Wi-Fi network. We'll also add a route to the ground control station so that you can ping the air unit and Raspberry Pi from that end. What you'll be able to do then is, from your ground control station, SSH into the Pi using its internal IP address on the drone's network, not the Wi-Fi one that it has. This will let you have long-range communication and essentially talk TCP/IP and make connections such as SSH or RTSP connections to the devices on your drone network. Lastly, we'll do a couple fun things. We're going to open a video stream from the HereLink in VLC Media Player on the ground control station. So we'll be able to see on the ground control station the Raspberry Pi screen, essentially. And then lastly, I'll show you a simple Python-based program that is executing mavlink commands, running on the Pi, spitting out basic telemetry from the flight controller. Okay. So on the next slide here, I have an overview of what the network looks like. Ultimately, we're building this on the drone. We already have an air unit, and your HereLink Air Unit has a hard-coded IP address at 192.168.144.10. So our Raspberry Pi has to have an IP address on that network. We're going to assign the Raspberry Pi the static IP address of 192.168.144.55 in this example. Okay. The drone network will be talking to the HereLink controller over its 2.4 gigahertz link. The HereLink controller also has a couple hard-coded IP addresses. It has essentially two networks in it. It has the drone network side talking to the air unit, which is at 192.168.144.11. And then when you enable the Wi-Fi access point, it gives itself an IP address of 192.168.43.1. The controller is able to route between these two networks, which is pretty cool in that it will let your Raspberry Pi talk all the way through this link, through the controller, to anything connected to the Wi-Fi access point on the other side. The ground control station It is connected to the HereLink controller over the Wi-Fi SSID that we set up in a previous video called HereLink, and it'll get a DHCP address somewhere in the range of 192.168.43. Whatever it assigns to it, right? So you can see that the ground control station and the HereLink side of the Wi-Fi access point are on the same network. And then there is the drone network that is on the 144 network, 192.168.144 dot whatever IP address. Okay. A couple other things that are important to note is you'll see later in the videos, you're able to pick up a RTSP video stream on either of these URLs from the controller. So RTSP 192.168.43.1, which is its Wi-Fi access point side of the network connection, or RTSP 192.168.144.11, which is the drone side of the network for the controller. I'll show you later, we'll be able to put these URLs into a tool called VLC Media Player, and you'll get the video stream that is essentially getting piped into the HereLink Air Unit over that HDMI port that we connected earlier. Okay. And then lastly, we're going to do a Python program that will be running on the Raspberry Pi. It will be executing mavlink commands and essentially reading telemetry from the flight controller and printing it out to the screen. It's kind of our first step towards autonomous flight. So this will be a pretty cool, pretty fun set of things that we're going to walk through in the remainder of this video. The last slide I want to show you again is this wiki page. So visit the wiki at github.com/timarcher/drone. It's going to make your life a whole lot easier if you can copy and paste the code and settings from there. To get there, let me show you where that's at. So in my browser, we're at github.com/timarcher/drone, and it's going to start you off at a page that looks like this. There's a README file. It'll show you some text for this Hexacopter build project, and there is a link that's going to take you right into the wiki and documentation I've been publishing. Click that link, and you will get to all the pages for all the videos. So on the left-hand side, we got video 1 through 12 now that I've been working on. This is video 10, the onboard computer and Ethernet that we're working on here. In case you haven't seen the earlier videos, there's a lot of content on this index page here talking about prep work in terms of flying your knowledge for flying your drone, safety, compliance types of things you may want to work through. The bill of materials, which is everything that I purchased so far for this drone and where I got it from. And then the actual links to the videos themselves are here in this, or actually the pages to the videos are here in this step-by-step build process. On each of these pages has some details that I wrote and a link to the underlying video. I want you to click on this video number 10, onboard computer and Ethernet, and go to the page here. Inside of this page, there's a bunch of notes. I kind of talk through all those networking connections below here, or on the previous PowerPoint that I was showing you. I also, if I scroll to the bottom, have a picture of that network set up here. Okay, so this is a very handy reference when you're wondering what IP address is at what, or what device is at what IP address. Additionally, when we're working through the rest of the steps, we're going to be copying and pasting from this section here to set your IP address on your Raspberry Pi and the appropriate route. And lastly, this section here is going to have the Python code that we're going to execute and the appropriate commands to set up your Raspberry Pi to be able to successfully execute Python on the drone. There is a link here that I want to point to the contents of this file. So this is a sample number 1 program that I've created. It's a simple mavlink test. And if you click on that, you'll see we get to some code that we'll be able to copy and paste later. So I wanted you to have all these at your fingertips so that as you work through the rest of this video, you can most easily follow along. All right, so our next step is we're going to be setting up a static IP address on our Raspberry Pi. So I'm going to pause the video here and get that ready to record, and then I'll show you how to start to walk through those steps. All right, I'm on the wiki page here, and there's the section for the onboard computer and Ethernet page that's titled Setting an IP Address on the Raspberry Pi. We're going to walk through those steps right now to give our Raspberry Pi the IP address 192.168.144.55 on the drone network. Now, my computer, my ground station that I'm at here, is connected to the Wi-Fi that the Raspberry Pi is connected to. It is not connected to my HereLink just yet. So you can see if I go show my Wi-Fi connections, I'm actually on this aesthetic Wi-Fi, okay, not the HereLink yet. Now what I'm going to do is I'm going to go to my terminal program. I use a program called MobaXterm. And if you remember earlier in this video, the Raspberry Pi IP address on my local network was 192.168.200.105, okay? That is not on the drone network. These are both connected to my Wi-Fi, home Wi-Fi network at this moment. So I'm going to go ahead and connect to this Raspberry Pi. And it went ahead and logged in. I'm at my command prompt. MobaXterm is free software, I think, for home use up to a certain amount of connections or for a certain trial period. But if you look down in this Ethernet or in this page about the Ethernet connections, I also have a download to a tool called PuTTY, which you may wish to use as well to SSH into your Raspberry Pi. Regardless, there is some basic knowledge that I'm assuming here that you have about Linux and networking and so forth. So once you're in the Raspberry Pi, let me stack these pages side by side. What we're going to do is run this first command, which is sudo vi/etc/netplan/01-netconfig.yaml. That is the network configuration file that we're going to edit here. So I'm going to paste that in over on the left-hand side, and I'm going to run that command. It's going to ask me for the password for my Raspberry Pi for the Ubuntu user that I set up. And it starts off with a blank page. VI can be a little bit cumbersome to use for new users. If so, go Google how to use Nano and edit the file with that. Replace the word VI with Nano, and it'll be a little bit more user-friendly. In VI, you have command modes, and you're in an edit mode. Right now I'm in a command mode where I can't just straight up type. I actually have to type the keyword I, and you can see in the lower left I'm in insert mode. So now I can start inserting stuff into this file. I'm going to go ahead and just copy this code block over here, the network version 2 Ethernets. And what we're saying here is we're configuring the ETH0 port with an IP address of 192.168.144.55. And it's going to be static, so it's not going to get it through DHCP. And we're also going to configure a route through the HereLink controller to be able to talk to the network on the Wi-Fi access point side of the HereLink controller. This is basically saying that if I want to talk to the network 192.168.43, I'm going to route through 192.168.144.11, which is my HereLink controller, the IP address on the drone network side. Okay, so since I copied this, I'm going to go ahead and just right click and paste it all over here. And these tabs and formatting are important. You have to kind of leave it indented like this or you'll have problems. So now in VI, you hit escape, shift colon, and you kind of get back to command mode. You see a colon in the lower left corner down here. And I'm going to type WQ enter for write quit. Okay, write the file and quit the program. Now we want to apply this network configuration. So I need to run this step here, sudo netplan apply. I'm going to copy that command and I'm going to paste it. And while that's running, I'm going to grab the next command, which is this IP address show ETH0. It's going to show how the ETH0 port is now configured after this finishes running on the left-hand side. Okay, you can see it's done. I got my command prompt back. If I paste again, you can see it prints out down here. ETH0 is this port. It has the address 192.168.144.55. Okay. Now, if you remember, if we go back to the PowerPoint I was showing earlier, what we did was just give this Raspberry Pi that Ethernet address. We should now be on the same network with the rest of the drone network, right? The air unit and the controller. So I should be able to go ping 192.168.144.10 and 144.11 and get a successful response if this is working. So let's go back and do that. I'm going to clear my screen here, and I'm going to type ping 192.168.144.11, which is the air unit, or actually 10, I'm going to ping .10, which is the air unit. Okay, so it's the air unit in the drone, and you can see I'm getting a response 1 to 2 milliseconds per ping here. Okay. I'm also going to ping 192.168.144.11. That's the controller. You can see slightly longer ping times because it's going out over the 2.4 gigahertz connection and pinging the controller unit itself. Okay, so what I just pinged in the second example here, and you hit Control C to stop pinging, but what I just pinged in the second example was this box here, 144.11. Now let's test 43.1. That's the Wi-Fi access point side of the HereLink controller. Okay. 43.1. And again, it is successfully talking to that side of the controller as well. Approximately the same ping times because it's basically the same device. All right. So now, let's go back to the steps. We assigned our Raspberry Pi a static IP address. Let's go back a slide. We ping the air unit and controller from Raspberry Pi. And we had a route in our configuration so you can ping the Wi-Fi access point from the Pi. Now what we want to do is be able to ping the Raspberry Pi from the ground control station. So in here, if I were to start a command prompt, and I want to start, I'm going to type CMD, and I'm going to right click and say run as administrator. Because I want to add a route in a second here, I'm going to need to be able to be the administrator. So I'm going to say yes. If I try and ping 192.168.143.55, which is the Raspberry Pi, or 144.55, I'm sorry, it's not able to talk to it. Okay? There's two issues going on here. A, I'm not on the HereLink Wi-Fi network, and B, my computer does not know how to route traffic to the .144 network. Okay, so to show you that, if I were to pull up my Wi-Fi connections, you can see Wi-Fi here on Windows. I'm running Windows 11. Right now I'm connected to a static Wi-Fi, which is the same Wi-Fi that my Raspberry Pi is connected to. I'm going to go ahead and show available networks, and you see the HereLink is in here. I'm going to go ahead and connect to that. Okay, and before I connect, while that's sitting there, just to prove, I also cannot ping the air unit or the controller. So 192.168.43.1. If you remember from our diagram, that's this here. It's telling me I'm not on the HereLink controller or Wi-Fi network. So let's go ahead and make that connection. HereLink connect. Now if I ping 192.168.43.1, I'm talking to the controller. Okay. And if I ping 192.168.144.11 or 10 or 55, none of those will work yet. 144.11. Oops, I must have actually... I left my route in place. Okay, so I was testing this earlier, but to be able to ping those, you actually have to run a command first on your Windows machine that adds a route to the 144 network. So I already ran this command, and I ran it with the -P flag, which makes it persistent, so it remembers across sessions. Because that's in here, that's why it's working. On your PC, prior to doing that route command, you will likely not be able to ping the 144.10 or 55 addresses. Okay, so what you want to do is, I got a command prompt that I ran as administrator, if you remember, and I'm going to right click and paste it. You would run a command like this on your PC: route -P add 192.168.144.0 mask 255.255.255.0, and you want to route that through 192.168.43.1. Okay. So that's going to set you up so that you can successfully route traffic to the Raspberry Pi. You can see I'm able to ping 192.168.144.55. If I also run the command ipconfig, you can see my wireless adapter has the address 192.168.43.134. That is the IP address that my ground control station has on the HereLink Wi-Fi network. If I were to go over to my Raspberry Pi, in fact, I lost the connection here because, if you remember, I dropped off the main Wi-Fi from my home that we're both connected to and connected to the HereLink. So this 192.168.200.105 will no longer connect right now. So if I start a new session and I go SSH 192.168.144.55, and I'm going to put in my username here, and then I'm going to put in my password. I'm now talking to the Raspberry Pi through its IP address on my local drone network. So in this scenario here, my traffic is coming from my ground control station, going over the Wi-Fi wireless link, through the HereLink controller, which is doing the translation and routing between the two networks, and then it's going up the HereLink wireless link to the Raspberry Pi. Okay. Now, last step here, 192.168.43.134. We can try and ping it. .134. I have the Windows firewall on, so it's not going to let pings through. But if you wanted to try it out, you could. This is driving me nuts. It keeps popping open that other one. So if I put in firewall, I can go Windows Defender Firewall and turn Windows Defender Firewall on or off. I can go ahead and turn it off real quick on all networks. We'll say OK. Now if I go back to the Raspberry Pi, you can see the pings are starting to respond. 192.168.43.134. Okay, so this is the Raspberry Pi pinging my ground control station. All right. So let's go turn the firewall back on. And you'll see I got them set to on. Once I hit OK, you're going to see these pings start timing out again in the SSH session over here. So if I turn that back on, you see they stop streaming. So nothing new is coming in. Okay. Let's go back to our PowerPoint here and double check where we're at. So we've added a route to be able to ping the Wi-Fi access point and a route to be able to the ground station so that we can ping the Air Unit and Raspberry Pi from the ground station. And we can SSH to the Pi now from the ground control station using its internal IP address and not the Wi-Fi one. So the next fun thing you can do is open a video stream from the HereLink in VLC Media Player on the ground control station. So this is kind of cool. For one, let me go to the next page. The ground control station is going to talk to the Air Unit, or actually to the HereLink controller, either of its IP addresses, and it will broadcast an RTSP video stream. The URLs are at the bottom of this PowerPoint here. And I also pasted them in this wiki page. So I'm under the notes section, and there is a URL for the RTSP video stream is, and then RTSP : and that full string there. So if I start a program called VLC Media Player, and if I scroll down here, I have a link in my wiki page to VLC Media Player. Go ahead and download and install that. And when you run it, you click on Media and Open Network Stream. I'm going to paste in this value that I copied down here for the RTSP video stream. Okay, so 192.168.43.1, port 8554/FPV_stream. And I'm going to say play. And you can see it pop open. It's the full display. And this is what would normally be showing on a monitor if it was plugged into the Raspberry Pi right now. Later on, we'll figure out how to get it to broadcast video feeds and so forth so that we can remotely view them, but that's what this allows you to do. The other IP address you can use here is just the other side of the HereLink controller because we set our routing in place. So 192.168.144.11. And if I do media, open network stream, and I paste that address in, I can hit play. You can see the address changed up here, the content didn't, because it's the same exact content, right? It's just getting broadcast through this HereLink controller. The video must be coming back over the 2.4 gigahertz link from the Air Unit, and the controller is rebroadcasting it as a RTSP stream. Okay. Another fun thing you can do, playing with these video feeds, if you were to open Mission Planner, let's start this up. It's going to auto detect the HereLink controller. I'm going to connect to it. Once it loads the params, I'll be able to drag this window over to the left so you can see it. I'm going to cancel. It looks like it's stalled out. So over here, I'm connected. I'm getting telemetry at least. It didn't download all the parameters, which is fine. If you were to right click in your kind of heads up display over here, you can go to video, HereLink video. And I put in the IP address 192.168.43.1. And you can see, probably it's going to be really hard in this video, that it's showing the same that we were seeing in VLC Media Player. Basically what would be on the monitor. And I can right click and I can say swap with map. And it'll put it back. So the map's over on the left and the heads up display is on the right now. And you might be able to kind of read if you zoom in on your PC and viewer here. It's saying up in the upper left, Ubuntu 2404, LTS. The login prompt is up here, and so on. So we can video, and we can swap that back. So you got your normal display. And then HereLink video. What it did was the Connect stream before the HereLink video. So this is what I put in here, 192.168.43.1. So in the video, or in the HereLink video, when this menu option shows up, you can also, I believe, select Connect Stream 1, V1. And then I think you might be able to pick V2 if you got a second video feed plugged in here and be able to swap between them. I haven't tried that out yet, but that's next on my list. Okay, so that's a lot of the fun stuff that you can do with this. Let's go back to our PowerPoint here. So the last thing I want to show is a simple Python-based Mavlink program on the Pi. All right. So what we're going to do there is go back to the wiki page, and you're going to scroll down to this Python and pymavlink section. Pymavlink is a Python library that'll let you parse and process and send Mavlink messages. Okay, Mavlink stands for the Micro Air Vehicle Link, and it's the communication protocol which will allow us to talk to our flight controller. You're going to need to do a few things first before this works. First of all, you need to install some dependencies. Okay, so you're going to run this command here, sudo apt update, and then ampersand sudo apt install, and we're going to put Python 3 full environment on your Raspberry Pi. We're going to install pip, and we're going to say that Python is Python 3, so that if you just type Python, that command, it'll know that you want the Python 3 executable versus the Python 2. So over on your Raspberry Pi, I just typed the word clear and cleared the screen. Well, I've already run through these commands, but you'll run them here, and it's going to download and install the programs if you don't already have them. And I can't remember what it took, maybe 5 minutes, maybe a little bit longer or something for it all to install on my Pi before. See, this is telling me it's already the newest version installed. If you just work through these instructions for the first time yourself, it'll likely be processing and installing at the moment. And then what you're able to do, notice there's no sudo in front of these commands, but we're going to use virtual environments in Python so that you can have many different environments, each with their own libraries and dependencies. So let me stack these two side by side again. So I'm going to use Python, and I'm going to make a virtual environment called Drone01. Now, I've already done this, so I don't know if it's going to fail or not, but we'll try it. Okay, so it is there. And the next step you got to do then is tell your system to activate that virtual environment. So you're going to run this command, source drone01, or whatever you named your virtual environment, /bin/activate. Now I want you to pay attention to this command prompt when I hit enter here. It's going to change very slightly. Now that I ran the activate command, it tells me in parentheses to the left of the command prompt, drone 01. It's a little bit of a reminder that you're in that Python virtual environment. The next thing you want to do is run pip install pymavlink. That is going to install the pymavlink packages, the Python packages, into that virtual environment. Now I've already run that, and so it didn't have to do much here. In your system, it will be downloading and installing that right now. And then the next step is you're going to use your favorite editor, remember VI or Nano, and you're going to make a file named sample01 underscore simple mavlink text.py. Okay, so if I do VI sample01 simple mavlink test.py and press enter, I'm getting an empty file. What I want to do is, there's a link here telling you to add the contents of this file to it. So I'm going to right click and open that in a new tab. When I go to that tab, you can see all the code in here that I want you to paste in. Let's talk through this code real quick. So I'm a bit stuck trying to, there you go, maximize this window. So what this code does is imports a couple Python libraries for exception handling, and the important one is this pymavlink. And I've got some functions defined in here for helper utilities. For example, lines 9 through 24 here is going to connect to your drone, and there's a method here that's taking in a connection string as the parameter. Okay. I've also found some issues in this current version of everything, that if you do this drone wait heartbeat before you send a ping, it won't ever connect. And so I had to add this ping. I found this on some of the forums. Thank you for whoever posted that. That do that before your wait heartbeat and you'll have a good connection. Okay. I also have a helper function that just sends a command to the drone. So you'll see this in a second, but to do various commands, you have to encode them correctly and send the appropriate structure, and then issue this command long send, and it will send the instructions over to the drone. So for example, you'll see that in this next helper function here, I have to set a message rate, right? Like I want to tell the system how often I want certain telemetry messages to come over. So you can see set message rate. I'm passing in the drone object, the message ID that I want to change, and the rate in hertz that I want it to be changed to. And you can see it calls the send command long, and it's passing in the drone and telling it that I want to set the message interval for a specific message type. And then I got to change this rate hertz. I'm just decoding that, and you got to actually send it in microseconds, and then a bunch of default values for param 1 through 7. I also have a function to read the telemetry. So it's just an infinite loop that's going to look for attitude information, GPS information, battery status, or just generic heartbeat messages. And it's going to print out a little bit of details about each of those once it receives the data. For example, the attitude, it's going to print out the pitch, roll, and the yaw of the drone. Okay, and this endless loop just sleeps for 5 milliseconds and then tries to read again. Lastly, I got a helper method to close the connection so we can gracefully shut down the connection to the Mavlink system. Okay. The last part glues all this together. So there is a main method where I have a connection string defined, and that is UDP out : 192.168.144.10 : 14552. So I'm talking to the HereLink Air Unit over port 14552. I'm going to call my helper method to connect to the drone, and I get a drone object back. I'm going to set up some interrupt handling, so if I hit Control C or kill the Python program, it's also going to try and gracefully call the the shutdown method on the drone, or on the to the connection. And then I have a try catch block where I'm going to set some message rates. So the attitude data from the drone, I want to come in at 10 hertz. GPS info, I want to come in at 10 hertz. Battery status every second, and heartbeat information every second. And then I start my infinite loop here by calling read telemetry, which you remember in that method itself is the infinite loop. Okay. And then you got some standard Python stuff on the very last lines that knows how to execute itself. You know, if I'm running the program, it's going to call this main method, which encapsulates the logic and executes everything. So if I just hit this raw button up here, I'm going to get a page where I can copy all this text. It's just the raw text that I want to paste in my Python program. And I'm going to go ahead and insert it all into this blank file that we created earlier. So I just right click to paste, escape shift WQ. So write and save. So our very last step now, let me go back to our wiki. I'm going to close this raw source code view. Is we're going to run it. Okay, so I'm going to run Python sample01 simple mavlink test.py. So if I paste that in, you're seeing a bunch of data starting to stream out now. Battery voltage 24.78, 82% remaining. The pitch values, the flight status is coming in the GPS. So I got flight mode, stabilize, armed is false. Attitude information, and then here's your GPS information too, latitude and longitude, altitude. Which I'm in a basement right now, so I don't got a good GPS fix, so it's likely not valid data. Okay. And that's it, right? So what we just created was a very simple network on board our drone. And we're able to run a program, a Raspberry Pi, that is able to talk to the air unit, which ultimately is talking with our flight controller. I probably should have drawn a box down here for flight controller, but you know, that's talking over a serial connection, I believe. So I'm going to go ahead and cut this video off here. That's a lot of content. This is a long video, but this lays the groundwork for having your own Ethernet network on your drone. So if you have any questions, go ahead and post them in the comments, and I'll try to answer them. I can't promise I can help everybody's unique situation, but at least this video shows how I executed my setup. So thanks for watching, and there'll be more videos to come on some of the additional capabilities I'm building into the drone. I got a video in the works on setting up another LiDAR, and I also have the smart battery that I need to set up and figure out how to get that information into the telemetry. And then we'll have our prototyping done for the most part of the basic electronics. Then I got to move on to the camera and prototype with that and figure out what camera I'm going to buy. And once that's done, we can assemble this whole thing, try and do our first test flight. So stay tuned. There's still lots more to come. We've made a lot of progress so far. Hopefully you're enjoying these videos. Have a good day. Thanks.